It sounds elementary. You've got a body of water that never freezes next to a city that does. So drill a hole into the waterfront, run a line to town, and Bob's your uncle. Unlimited heat, right? While it may not take a genius to come up with the idea, executing it takes several. And today we'll meet a trio of geniuses working to make this idea a reality for Seward.
The city of Seward is an amazing place for a demonstration project because we have a small coastal city very much in need of lower cost heat energy. Right now, they have heating oil as their primary source. There's no natural gas. And so the community is very motivated to innovate new ways to heat their buildings and make use of nature. And in this case, we have this wonderful heat resource in the bay.
It's become known as the Heat Loop Project. Environmental engineer and Your Clean Energy founder Andy Baker got involved back in 2015.
The basic project is to heat 4 city buildings using a CO2 heat pump system that's drawing source heat from Resurrection Bay.
Baker designed a similar system for the Alaska Sea Life Center. That system pumped water directly from the sea, but no need for that in the heat loop, he says, because it will use a more advanced technology.
Rather than pumping seawater through a heat exchanger, we're going to be putting geothermal loops down in the deep gravel right next to the bay and exchanging heat with the tidal flush, bringing that heat into the library basement. That will go into a CO2 heat pump system, and that heat pump system will lift the hydronic water to heat the library, the city annex, the city hall, and the fire hall, and inject heat just before the boilers do. So the heat pump system will become the primary heat source for those buildings, and the boilers will be supplemental or backup heat. This can be done at a lower cost and without the carbon footprint of burning oil.
Lower cost, yes, but with a hefty upfront price tag. Earlier estimates weighed in at $4.5 million, and inflation has driven that figure even higher. But in 2022, the city formed a volunteer community coalition, and with Baker's help, they were able to secure a design grant from the U.S. Department of Energy.
This project has recently received DOE funding for final design, which will wrap up in September, and then we'll be competing with 11 other projects across the nation, geothermal projects, for Phase 2 funding for construction.
But a number of milestones must still be reached before the September deadline. Last year, scientists from the National Renewable Energy Laboratory, or NREL, visited Seward and dropped 300 feet of sensor equipment into a waterfront test well to collect the data that will inform the design.
The role of NREL is to do the measurements and then use the measurements to do a simulation model for the system.
Saqib Javed is the newest member of the NREL team to join the project and holds a PhD in energy and environment. Javed came to Seward on May 14th to retrieve data on the water's pressure, temperature, and salinity trends throughout the last season.
We are collecting experimental data which will be used as an input to simulate the results before we can actually go and build the system.
A comprehensive data set is necessary, Javed says, given the unique nature of the project.
It is not a typical geothermal system. It is a system which is different from a traditional geothermal system because it's influenced by the seawater influx. So we want to take the measurements here and use the actual data instead of using the typical geothermal data which would be used in any other project.
In my experience, everything that gets done in Alaska is a little bit different than the way it's done anywhere else. So every project I've worked on is unique in some way.
NREL environmental scientist Karlin Swearingen accompanied Javed to Seward for the data collection.
It'll help us determine how much the water and the ground temperature is influenced by the tides, but also by rainwater, snowmelt water, the fresh water that's going to sit on top of the salt water. So this will give us a good idea of how to finalize the numbers of wells and the way they'll be installed.
Swearingen was part of the team that originally installed the sensors last autumn.
The sensors were placed down well at the beginning of November. I remembered because I was like, oh, there was leftover Halloween candy everywhere.
The measurements started in November and they will end in October. And the objective of this data is to get accurate temperature profiles for all months of the year to be used for modeling purposes.
The information was downloaded from them in January, and then again yesterday, May 14th, and then they were redeployed downwell and will collect a summer data set.
After the final collection season, the sensors will be pulled from the well and returned to the National Renewable Energy Lab.
The city will be the ones pulling the sensors, they'll ship them to us, and then we can download the data.
The NREL team had installed temperature sensors in each of the targeted buildings during a previous visit, and these sensors were also retrieved as part of this season's data collection.
On the buildings, we did energy data collection and analysis, fuel use, electricity use, what types of internal heat gains or heat loads there are in the building. And then we also did blower door tests to check the air leakage through the building envelope. And then we used known energy usage to calibrate our models of the buildings.
The pair were joined on May 15th by Andy Baker, and the three of them took to the rooftops downtown to track the sun's path in preparation for the photovoltaic panels now included in Baker's expanded plans.
The project will also incorporate some rooftop solar PV to make clean electricity to offset some of the grid electricity that we'd have to purchase from the city electric to run the heat pump system.
So we're looking at the seasonal solar path and graphing the solar path across a picture of the sky taken through the photo of a 180 fisheye lens, so that we could do an analysis of shading from trees, power lines, communication equipment, the edge of the building, the mountains around, and then we have normalized annual weather data to account for cloud cover.
Also included in Baker's latest plan is a system to melt the snow on the sidewalks around the targeted buildings.
We will be using this same heat pump heat to melt the snow on the sidewalk around the library and along the front of City Hall.
We would be modeling the integration of the photovoltaics, the PV panels, and also the snow melt system as design options. So all these things will take a lot of time in terms of modeling effort. There is still a lot of work to be done in this project.
So we'll call the Heat Loop Committee for May 15th meeting to order.
At the May 15th meeting of the Community Coalition, plans were discussed to incorporate the new elements into the overall design. Moose Pass resident Bruce Jaffa chairs the coalition.
If you could incorporate the photovoltaic, the solar or sidewalk heating, or the building system, if any of those things can be piggybacked onto our grant without hurting the DOE grant, this is the time to do it.
Solar PV and the outdoor snow melt, which I feel is imperative for this project because it will give us this low temperature load that we badly need for those heat pumps. There's not money in the original scope for those.
While not included in the Department of Energy grant, the project has already received a number of secondary funding awards. A $750,000 State Department of Energy grant will go toward the city's 10% matching share of the federal grant. And more recently, the project received a second federal grant in the amount of $500,000, thanks in part to the efforts of U.S. Representative Mary Peltola.
We have an additional federal grant. It cannot be used as a match towards the scope that we have. But I'm going to openly suggest that we consider using that grant to help pay for a sidewalk, snow melt system, and solar PV. That will supplement the project in the most beneficial way that I can think of.
All design phase requirements must be submitted by August 31st in order for the city to compete for federal deployment funds.
I think Seward has a very good chance because there's a very high public benefit. So many people use the library and the fire hall and the annex and the city hall. So unlike a private developed project that may just benefit those people who may live there, this benefits the entire area of Seward.
An analysis of the NREL data is expected within the coming weeks, then a final sprint to the September deadline.
My next step as the engineer is to receive the data we need from the test well from NREL. They're also building a system model. And then the next step is to get that final design expressed in the drawings, specifications, and cost estimate. That will go into the grant application package for the Phase 2 competition for construction money.
The preceding presentation was written, produced, and narrated by Sam McDavid for the Seward Heat Loop project, with an additional voiceover by Shiloh Whitson. All music tracks, Samba Isabel, Bossa Antigua, and Crinoline Dreams, are the sole copyright of Kevin MacLeod, licensed under the Creative Commons License 4.0. To learn more about the Seward Heat Loop project, visit heatloopseward, all one word, .weebly.com.